Hey guys, welcome back to my YouTube channel. In this video, we are going to solve Palindrome Linked List. It's on a lead code. The problem number is 234. I will provide the problem link into the description box so you can directly jump to the problem from there. So what this problem is saying that you have given the head of a singly linked list and you have to check if the linked list is palindrome or not. So palindrome basically means it should be the same from the both end, means it should be the same from the front edge, but from the back means the first element should be the same as the last element. The second element should be the same as the second last. If there was a third element, it should be the same to the third last and so on. And you can see in example 2, the first node should be the same to the last node to be a palindrome, but they are not same means it's not a palindrome. So you can simply return false. So in a brute force, what we can do, we can simply reverse the linked list. Okay, then we start comparing the two linked lists one by one. Means if I reverse this linked list, it will become 1, 2, 2, 1. So basically, I am converting this head with the new. You got the new linked list of the reverse version of the new head. New head. Suppose let's say new head. Okay, then you are basically comparing this with a this, then this with a this again this with a this, and then this with a this. So that will be our brute force. We are reversing the whole linked list, then comparing them one by one. And if they are not same at some node, then you can directly return false from there. If you are out of the while loop, then you can simply return true, means they are same. But do we need to reverse the whole linked list? If somehow I reverse the second half only, means it's become 1 and it's become 2, then I can simply compare this node 1 with this node and then this node with this node. Let's check its approach into detail. So suppose you have a linked list, okay, of there's 8 node, 4 and 4. So if I reverse only the second half, okay, it will be something like of this. Okay, so if I reverse one, 4 will become 1, 3 will become 2, 2 will become 3, and 4, 1 will become 4. Okay, so if I compare this node with this node, they are same. This node with this node, this node with this 3 node, then 4 with a 4. If they are same, then you can simply say they are palindrome. If they are not same, means they are not palindrome. So instead of reversing the whole linked list, you can simply reverse the second half and then you can compare, because the first half should be the same as the second half in the reverse order. So how would you approach it? I have said that first you have to reverse, first you have to find the middle. So after, so you can reverse the second half. So first you have to find the middle, then you have to reverse the second half, then you will cut, then you will again start comparing them. So it's basically a three-step approach. So how, the first question is, how will you find the middle? Tell me exactly. Slow fast, by using the slow fast approach. I have taught about slow fast approach, or you can see to find the middle element in my previous video. You can check out from my playlist. So first you will see slow fast to be had, then you will move slow by 1, fast by 2, then again fast by 2, slow should be here, sorry, it's not here, slow will be here somewhere, and the fast will be here, then again my slow moves here, my fast moves here, then again my slow moves here, my fast moves to the null. So you can see that my slow is pointing to the second half portion. So you can simply create a function where it will take a head, means it will take a slow, and it will reverse it. So my reverse array will be something like it, and it will return the head, means it will return the first node, and then you can directly compare with this one. So again this, then two node with a two, second, third with node with a third node, fourth node with the fourth node. Okay, you will get how to find the middle of a linked list, but how will you reverse it? So of course I have taught it in my previous video, so I'm not going to explain it truly. So, but I will try to make you understand by okay. So what we have done is you will get a head of a linked list that is slow. My slow will be pointing here. You will pass on a function and you will create a node prev. Initially the prev will be null. What you will do, you will broke this link and point it into the prev, means it is pointing to null. Okay, after that you can simply say prev, can you move here? Okay, prev, so prev moves here, but but how if this link is broken, then you won't be able to access it. So you can simply say first create the node. Suppose you are creating a node here next and pointing it to head the my next would be the head of next. Then you can broke this link and point it to the prev. Then you can simply move to prev to the head and then head to the next. Then again you can simply say broke this link and point it to the forward, then perhaps moves, and again the same thing, again the same thing, again the same thing. So you can see, and after that you can simply return pref from here, means it's the head of the linked list, the second half portion of the linked list, you can say. So you can simply return the pref from here, and after that you can simply compare this node with this node and so on. So let's try to code it up and see whether it's working or not. So first what we have to do is to find the middle. So let's find the middle. So I'm creating my slow equals to head, my list node fast equal to head. Then what we need, while my slow, while my fast and my fast of next of my fast, they both should not be null. And in the while loop, what I need to do, I will just assign my slow. Can you move to your next? And my fast, it will move next of fast. It's moving two step. Okay. So after this while loop, slow will be pointing to the second half. So you can directly simply say, let me create list node new head and simply call a function, let's suppose reverse. Okay, I hope there's not any inbuilt function of reverse. And let's just pass the slow. It will give me the head of the reverse linked list. I mean the second half portion in the reverse order. After that, what we need to do, I will simply say while my while my new head is not equal to null, or in C plus is same. And in the new head, what I need to do is if my new head is not equal to my head, I will simply return false. Return false. Okay, but I have to compare the value. not the node. Okay, okay, yeah, it's a well, and I am comparing with the well. If they are not same, means it's not a palindrome, and you can simply return it. And if not, then you have to move your new head by one. So new head, can you move to the next? And same for the my head. Head, can you move to your next? Okay. After that, if my while loop got exhausted, means it's a palindrome. So you can simply return true. And now we have to build this reverse function. So let's just create a function called, let's just create a private first. Reverse link list node. Sorry, I don't know what I'm writing it. List node reverse type. It should be taking a list node head. You can say head or slow. Let's just slow. What it will do? It will let's create a list node. List node what? Brave should be null initially, and I have what I need to do. While my slow is not null, I will reversing in. And what I need to do, I need to create a next node which will be storing the next of the slow. So list node next equals to next of slow, and I will have to break the node between the slow and the next of slow. So I was just pointing out the slow. Can you point to your prev? So basically my next of slow will be pointing to the prev, and I will simply say prev, can you move to your head, and head, can you move to your next. And after that I can simply return the prev. Okay, but it's not a Java solution. It's a C plus solution. So let me just copy the whole thing because I just saw it that I'm writing in a Java. So let me come here and let me just paste it here over here, and the same thing for this thing. Control C, Control V. Now will that be working? I think it should be working. A pray because you had sorry, there is not any head. It should be slow, and my slow will be next. Okay, it's running. Let's submit it up and let's move to the Java solution. Okay, I don't think I have to do multiple thing here. I just have to remove this from the Java, and it should be the null in small. Let's remove this instead of this dot. Let's do something. Let's do smart work. Okay, so instead of that, you can simply replace with dot. Okay, and asterisk with nothing. You can, yeah, replace with nothing. Let's just space and null. Yeah, of course, null with small null. Replace all occurrence of it. Okay, anything else we need to though it should not be equal to null, and same for this one. And let's run it. Okay, wow, it shows a okay. Let me just erase it and null. Now let's run it. Okay, oh, I got it. By mistake, we have removed this thing, so let's just comment it out. Okay, so basically, there was the comment, and now I think it should be running. Wait. Why my whole code got commented? Because of this thing. Now I think it should be running. It should be. Let's see. It's taking a lot of time. My symbol cannot be found because prayer because to head. Where is the head? It was a slow now. Okay. I was edited in C++. Okay. And I think now I think it should be running. Okay. It's happened. Sometimes it's happened. And it's running. So I think you got the intuition behind this problem. So basically, it was a three-step problem. First, you have to find the middle, then reverse the second half, then again start comparing the first head of this portion and the head of this portion, basically the second half portion. If they're matching, you can. If they're not matching, you can simply return the false, and if they're matching, you can simply return the true after the while loop. So with this, if you like my video, do like, subscribe, and if you have some comment, do comment below. With this, I am wrapping this video.